So we have two, I think. One, let me say this. If we had all put in applications in the first quarter of this year for renewable heat incentive, on average, about 5 of those, maybe 4 of those, would have been accepted. In the first quarter of this year, 95% of renewable heat incentive applications were sent back to the applicant, and that was typically because information provided with the application was incomplete or insufficient. In most cases, according to DEC and Ofgem, it goes back to metering and, in fact, to our last presenter, and the importance of making sure that full metering data requirements and the existing situation is set out fully in the application. So I just want to set out that general point on renewable heat incentive first before coming on. I'm going to talk in the main about a different heat technology. We've heard at the start about biomass. I want to talk to you about heat pumps, but heat pumps in a particular configuration, heat pumps combined with another technology, a technology called fuel cells. And the combination of heat pump and fuel cell can really provide a very attractive both power and heating solution. If anyone standing at the back wants to come and grab a seat, then do come and do that just now. So, I'm Managing Director of iPower. Just a very quick word. We are an energy services company. We provide services to social landlords and to a whole range of other groups, commercial, industrial and housing. We're what we call a social ESCO. We ourselves are structured as a social enterprise. The way we have done that means that we can provide the best returns to a building owner consistent with their appetite to take risk. In other words, what we will do is say, we won't maximise our profit from you. We will start by saying, where do you sit? How much risk do you want to take on? And build a solution around the answer to that question. Our motto is turning cleaner energy into cheaper energy, both for business and domestic customers. The I in iPower stands first for inclusion, including low-income households, particularly through social landlords, but that's certainly not to the exclusion of higher-income communities where we have very good projects being developed and indeed non-domestic. I also stands for innovation, and you'll see some of that in this presentation. So let me start off with fuel cell micro combined heat and power. What is that? It's a new way to turn gas into power and heat in either the home or the small business building. We sum it up as like a battery, more like a battery than a boiler or a generator, in that there is no combustion as there would be in a boiler. There are no moving parts in the way that you would have in a generator. It's purely an electrochemical reaction as you would have in a battery. The difference with a battery is that there's a constant flow of an input. In this case, typically we use the same natural gas that comes into homes and businesses through our gas pipe network. And there's a constant generation of electricity and heat. In short, it has the efficiency of a big gas-fired power station. That's about 60% efficiency. If you close your eyes for a moment and think or picture a gas-fired power station, my guess is what you'll envisage is something shaped like this, a large cooling tower, and what that cooling tower is sending waste heat up into the atmosphere. With fuel cell micro CHP, because it's generating heat on site, that heat can be used rather than wasted, and that increases the efficiency. Equally, there are not hundreds of miles of electricity pylons and cables, so one doesn't have the transmission losses. So if one starts with the same generating efficiency as a large gas power station, but then you have two pluses. You can use the heat rather than waste it, and you don't have transmission and distribution losses. The total system efficiency is much higher, and at the moment it is fair to say this is the most efficient means we have of turning gas into energy. So why install fuel cell CHP? Well, lower energy bills. It depends on the particular case, but typically for a micro fuel cell installation, about 4.5 tons of CO2 reduction per year for each unit, and saving money on both heat and power. However, there is a high initial cost. A typical blue gen unit, and I'll come on to the unit that is currently accredited, will cost $20,000, $22,000 perhaps for an individual installation. It makes sense over the long term, but that high upfront cost suggests a new business model. So that's why we are providing an energy services model where we're able to meet the upfront cost. iPower is working with a manufacturer called CFCL and a distributor called Burden of BlueGen. It's the only MCS accredited fuel cell micro CHP device in the UK. It's just turned 1 million hours of operational experience. Although it's new to the UK, it's been well established in Australia, where it's been developed, and in Germany and Holland, and is now ripe for deployment in the UK. There will be others in 2 or 3 times. We expect other micro CHP, fuel cell micro CHP units to come alongside BlueGen. For the moment, it is the single provider in the UK. It's about the size of a washing machine, generates enough electricity for 4 typical smaller homes, social landlord type homes, enough for a large executive home. But if one's providing heat through an electric means as well, then it will much increase the amount of electricity that can be met through the BlueGen unit. For an existing home, it would typically, on a smaller home, need about twice the hot water need of that home. But for a new home built to code level 4 or above, then it would provide the complete space heating and hot water requirement. So for an existing less efficient home, it does need to combine with another heat source, typically a combi boiler. That's what's already there, but works best with heat pumps, either ground or air source. And therefore that ground source and BlueGen combination can work with renewable heat incentive right now. We would hope next year with air source heat pumps, including RHI, that combination will also work. So this product, I think, will win the prize as aesthetically the most boring bit of high-tech kit you can imagine. It does look just a washing machine size square box, as you see there. The picture in the middle is not to the same scale, it's much smaller, and that is the actual fuel stack, which is hidden inside the washing machine-sized box. So here we have just a picture with an internal location. These can be externally located with proper weather protection, and for typical smaller homes, we are most usually planning on, as one would with a heat pump, externally situated against the rear wall. So here's a few figures, and I won't go through the whole of this. I'll just jump to the key thing. What we've done is take, on a very conservative basis, a situation with a gas boiler, with a heat pump working with grid electricity, and then a combination of fuel cell and heat pump. So if I start off on the first line, we've just assumed that the consumer is buying gas at 3.6p, maybe that's a bit more now, and grid electricity at 12.5p, again, maybe more or less than that. So whatever the solution, with the gas boiler, you're paying 3.6p for the fuel coming in. With grid electricity, you'd be paying 12.5p for the electricity coming in. With a fuel cell, which works off piped natural gas, you're paying the same 3.6p for the gas fuel coming in. If we move two lines down to efficiency, a gas boiler typically is assessed as working at 90% efficiency for 100 kilowatt hours of energy coming in, 90 kilowatt hours of heat come out. Now, for a heat pump works by leveraging value, so we get a multiple. Now here, we've been very conservative with a COP of 1 to 3 or 300% efficiency. I think in many cases with a heat pump these days, one might look particularly at a ground source heat pump at 5 to 1 or above, but I've been very conservative. We've looked at 3 to 1, and therefore it has a 300% efficiency. What that means is for 100 kilowatt hours of energy going in, 300 kilowatt hours of heat come out. Now, if we go to the line below, then, or two lines down, the cost per kilowatt hour of heat. On the first column, if a gas boiler, if the fuel input is 3.6p, if it's got 90% efficiency, then the actual cost of a kilowatt of heat is 4p. With grid electricity on this conservative 3 to 1 ratio, and electricity costing 12.5p, then the cost of a kilowatt hour of heat is about the same. Now, with 1 to 5, you would be in profit over gas as well. So we're being a bit unfair to the heat pump in that comparison. But the final column for us is the interesting one. Efficiency, we've said there at 85%. That's the combined total efficiency of the fuel cell unit. And what we're doing is taking the 300% efficiency of the heat pump and then the 85% efficiency of the fuel cell. So you're taking the 3.6p cost of the fuel coming in to our fuel cell, multiplying that by 85% to get the energy coming out of the fuel cell, and then by 300%. We've actually put an asterisk note there saying 400%, and we've added on a further factor for the use of the hot water. There's 200 litres of hot water, which could simply go as preheated hot water into the thermal store, into the hot water tank of the system. And on that basis, the cost per kilowatt hour is about 1 penny. So what this does, it is quite complex. One would need perhaps a bit more time to digest fully, but the net upshot of that is that one's getting, by a combination of fuel cell and heat pump, a very low cost, around 1 penny a cost for one's meeting one's heat requirement, and a very considerable CO2 saving, and that can be monetised through CRC or other mechanisms. So a business case outline. Now this assumes a smaller business property or a larger domestic property, or in the social landlord sector, we're grouping 4 homes, maybe in a terrace, or 4 in a block homes, 4 homes in a single unit. Assuming a property is using around 15,000 kilowatt hours electric a year and around 20,000 kilowatt hours thermal, in the latter case a fairly typical figure. In the first case, just considering the fuel cell on its own, the capital cost is met by feed-in tariff. At the moment, we'd expect with a break-even payback period of about year 9. But a net annual benefit we'd expect before and after that, over and above that, of about £600 per year. The ground source heat pump, once again, the capital cost met from RHI in a similar way as we saw with the figures from Wood Energy on biomass. The RHI is amply able to meet the capital cost of the heat pump, and there would be many years of RHI once that has been paid back. What the payback period is depends on the type of heat pump, air source heat pump, ground source, and so on. But without the fuel cell, as we saw on the conservative 3-to-1 COP, then it was just about breaking even with gas as a cost of heat coming out. With 5-to-1, it would be ahead of gas, it's fair to say. However, with the fuel cell in combination, it's saving about £580 on that illustration a year in heating costs. Now, on the final note, if the building wouldn't have had 15,000 kilowatt hours electric demand without the heat pump, then effectively the heat pump is helping to build up the electricity demand to get to that kind of level and make the business case for the fuel cell. It's the combination which work very well together. Otherwise, there would be a bit of double counting between those two sets of benefits. The key thing is electricity used on site is worth a lot more than electricity exported. So, business model options. The occupier owns the kit, perhaps with Green Deal support, whether they're a householder or a business. They may apply for Green Deal, and they would own the kit and take responsibility for all Green Deal servicing and receive all the income. They would have complete risk responsibility on that option, and some people we think that would be the right solution for. But in most cases, from people we've talked to, they prefer an energy services option where someone like ourselves meets the capital cost and provides an energy contract to them with guaranteed savings against benchmark energy prices. And that offers the potential for the property owner to avoid risk and capital outlay while still attracting maximum benefit. So our role as an energy services company, in our case what we call a social ESCO or CESCO, we develop, fund and manage energy services to the occupier, optimise the project structure, minimise risk. We purchase and own the property assets and manage and pay for maintenance contracts and any repairs. We receive customer income and Feed In Tariff and RHI income. And optimise and receive income from export of power. There's lots of work that can be done on scale, taking a portfolio in terms of optimising relationship with the grid and other providers that simply wouldn't be available to an individual customer. So that's an ESCO model. That's our model. It's a fairly typical ESCO model. I won't dwell on it now. If there is time in questions answer you like, I could come back. But essentially it says we handle a complex set of contractual relationships to give the customer a simple solution which gives a contract to them for cheaper energy. So when BlueGen has completed technical trials, it's now ready in the UK for commercial deployment. In Japan, with a different product, fuel cell micro CHP installations have grown from 0 to 20,000 in the last 3 years and are confidently predicted to be on a run rate of 50,000 a year in 2 years' time. We are seeing that step change happening, and I think at a policy level, coming back to the discussion right at the start of this session, one can see a large-scale implementation of these effectively as a large distributed gas-fired power station, and one that would be a lot more efficient than simply one new central large-scale gas power station. So strategically, it makes sense as part of our energy mix, but for the customer, it makes sense by reducing their energy bills, reducing their carbon emissions. We're starting in the current 2012-13 year with an aim of hundreds of installs shifting to thousands in 2013. So we are interested in talking to you, whether you are a solution provider, you provide a range of energy solutions to customers, or whether you're a building owner wanting to find the most efficient solution for your building. Come and talk to us. Thank you.